Arthur Francis Deban. Today we're going to be dealing with mole concept. Now, in mole concept, we are concentrating on the mole, which is amount, the mass, volume, atom, and so on. So when we talk about the concept, we talk about the various relationships that exist between these parameters which I just made mention of. For example, we have the mole-mass relationship, we have the mass relationship, we have the mass-volume relationship, and so on and so forth. So we're going to define them in that order and be able to solve them applicably in accordance to the questions that will be asked. So, mole concept, permit me to say, we say the mole is the amount of substances which contains Avogadro number of particles. All right. Now, whether atoms, molecules, ions, electrons, protons, neutrons, etc. So, the accepted value for the Avogadro number or Avogadro's constant is 6.02 times 10 raised to the power 23. So that is the standard. In chemical calculations, the symbol of an element stands for 1 mole of that element, which is equal to the relative atomic mass of that element expressed in grams. So here we're going to talk about what a symbol of an element represents. 1 mole of that symbol represent how many grams if we have to put it in grams. Represent how many atoms if we have to put it in atoms. It represent how many volumes, amount of volume, if you want to put it in what volume. So we're going to start with the mole-mass relationship. But before we go down to the mole-mass relationship, let me establish that relationship, which I want us to understand the basic principles of application before we proceed further. Alright? So now this is it. Let's take, for example, we have sodium. 1 mole of sodium is equivalent, let's call it 1 mole of sodium is equivalent to 23 grams of sodium. 1 mole of sodium is equivalent to 22.4 dm cube of sodium. That is the volume. 1 mole of sodium is equivalent to this in volume. 1 mole of sodium is equivalent to this in grams. 1 mole of sodium is equivalent to 6.02 times 10 raised to the power 23 atoms of sodium. So interchangeably, this is equivalent to this. So in many instances, if I am dealing with mass-volume relationship of sodium, I will be taking 23 grams of sodium to 22.4 dm cube of sodium. This is a statutory word background, which is constant. This is not induced. It is from the word formula, from the symbol here, sodium. That's how we achieve that. This equivalently will be the same thing if I'm dealing with calcium. 1 mole of calcium is equivalent to 40 grams of sodium. And the same thing as 1 mole of these is equivalent to 6.02 times 10 raised to the power 23 atoms. And 1 mole of that is equivalent to 22.4 dm cube of calcium. So this go on and on. Even in a balanced equation where we have the two reactants coming together to give us the product, we can still calculate the same thing of one of the reacting particles with probably one of the product. Try to relate the mass and volume, or volume, or whatever the case may be. You will see as we proceed in terms of solving what questions. Let's take our first question. Calculate the number of moles. So the first one is mole-mass relationship. So let's take our A, we call it mole-mass relationship. So in mole-mass relationship means our first variable here is the mole. Then we look at our mass and so on. Let's take a question. Calculate the number of moles. The first thing is the moles in 1.58 grams. The number of moles in 1.58 grams of solid potassium tetraozomanganate 7, that is in KMNO4. Is it calculate the number of moles? The question now again, calculate the number of moles in 1.58 grams of potassium tetraozomanganate 7 that is given. So they will always give us the relative molecular mass of this. They gave it to us from, or we can derive it. It's 158 in order to not to waste time. You calculate this 39, manganese will be given, oxygen 16 times 4 and other, so it's 158 generally. So solution. Now I have my KMNO4. It is mole mass relationship. That is the standard. So I want to begin. 1 mole of this is equivalent to how many mass of KMNO4? The relative molecular mass of this is the equivalent to 158 grams. Now, how many moles of KMNO4 will give me 1.58 gram? That is the question now. So my X mole will be 1 mole times 1.58 gram divided by 158 gram, and that is equals to, we have to use our calculator. Oh, finally. So I have my 1.58 times 1 is the same, divide by 158 gram, I have 0.01. So my answer is 0.01. What's the unit? Gram to go. I'm left with mole, 0.01 mole. So that is the first thing, or the first question we are calculating. It is mole mass relationship. Let's take question number 2. Calculate the number of moles in 6 grams of triazonitrate acid. Number of moles in 6 grams of triazonitrate acid. We are calculating the number of moles. So this has been given. So the question solution, I have my HNO3 here. Remember, it's mole mass relationship. 1 mole of this HNO3 is equivalent to how many grams of this? So now we have to calculate our relative molecular mass for HNO3 if it is not given, but quite often it will be given, but if it is not given, you calculate it. So let's check the relative molecular mass. Hydrogen is 1 plus nitrogen is 14 plus oxygen is 16 times 3. So if I have to check my 16 times 3, I have 48 plus 15 plus 15, I have, oh sorry, my calculator is misbehaving. 16 times 3, which is 48, plus 15, that gives me 63 grams. So it's 63 grams. So now, 1 mole of HNO3 is equivalent to 63 grams. These values are gotten from just this. The mole concept gives us that relationship. 1 mole of this is equivalent to 63 grams of what? HNO3. So how many moles will give me 6 grams? That's the question now. So I have my X, which is this times this divided by this. Alright? Cross multiply. So 1 mole times 6 grams divided by 63 grams, and that is equals to, so we just call it 6 divided by 63. 6 divided by 63, I have 0.0952. 0.0952 mole. Because this gram, you can see this gram. So that's our question number 2 on mole-mass relationship. So let's take the third question. Let me clean again. The third question says, calculate the number of moles in 5.6 grams of iron. 5.6 grams of iron. I should calculate the number of moles. I have my iron solution. Sorry. This is solution. I have my iron, which is this. Now, mole mass relationship. 1 mole of this is equivalent to, I think that should be 50. Let's check if it is not given, we have to determine that. Okay, it's given to be 56. Equivalent to 56 grams. So this is the standard. 1 mole of iron is equivalent to 56 grams of iron. That is a standard. It is not gotten from anywhere. It's from the question iron. From mole concept, which is mole mass. 1 mole of iron is equivalent to 56 grams. I established this. Then now the question now says, how many moles of iron can be gotten in 5.6 grams? So the question is, how many moles can be gotten in 5.6 grams? So if I make X my subject or formula, this is equals to 1 mole times 5.6 gram over 56 gram, and this is equals to 5.6 divided by 56. 5.6 divided by 56 is equals to 0.1. So 0.1, chemistry will leave 3 significant figures, so it becomes 100 mole. This gram will cancel this. So this is our third question, if I'm not mistaken. Let's take our fourth question. Okay? Okay, calculate the number of moles in 1.4 grams of nitrogen molecule. 1.4 grams of nitrogen molecule solution. We should calculate the number of moles in 1.4 grams of nitrogen molecule. So if I have my nitrogen molecule here, 1 mole of nitrogen molecule is equivalent to 14 times 2, which is 28 grams of nitrogen molecule. So this is a standard. 1 mole of this gives me 28 grams of this. That is unique. So the next thing now is, how many moles will give me 1.4 grams? How many moles will give me 1.4 grams? So I have my X is equals to 1 mole times 1.4 gram over 28 grams. This is equals to, so I have to check 1.4 divided by 28. 1.4 divided by 28 is equals to 0.05. So this is 0.0500 mole, because gram go. So we are still on mole mass relationship. Do we have more questions? Now, okay, I don't know if we should take one more. Okay, let's take one more. Now, calculate the number of moles of the following substances. 32 grams of oxygen atom, 35.5 grams of chlorine molecule. Those ones could be like your assignment. Alright? Take them as the assignment. Calculate the number of moles of the following substances. 32 grams of oxygen atom. This is oxygen atom. This is oxygen molecule. Don't forget that. So, 35.5 grams of chlorine molecule. This is chlorine atom. This is chlorine molecule. So, you should not get yourself confused. So, aside that, we're done with mole-mass relationship. Let's look at another relationship, which is mass-mole relationship. So we are in mass-mole relationship. The first question, calculate in grams, that's the mass, the masses of 5.5 moles of silver. 5.5 moles of silver, Ag. And this is, Ag is 105 or 108. Let's see if it is given. Okay, it's 108. 108 grams. The relative molecular mass of silver is 108. So we're looking for its mass-mole relationship. They say calculate, where is it? Calculate in grams the masses of 5.5 moles of silver. So solution. This is my silver. Let me establish. Remember, mass mole. Now, the number of grams, 108 grams, which is the mass, is equivalent to how many moles of silver? 1 mole of silver. Now, how many grams will give me 5.5 mole? That is it. Now we're dealing with mass-mole relationship. 108 grams is equivalent to 1 mole because the mole, it is mole, so 1 mole of silver is equivalent to this too. So how many grams will give us this mole? So my X obviously becomes 108 grams times 5.5 mole divided by 1 mole. The mole will cancel itself and I will be having 108 times 5.5. 108 times 5.5. That is 594. This is 594 grams. Okay, that's correct. So we've taken our first question. We're still on mass-mole relationship. Let's take the second one. Calculate in grams, which is mass, the mass of 0.05 mole of tetraoxosulfate 6 acid. 0.05 mole. mole of H2SO4. Solution. Okay, I have my H2SO4. Like I said, if the relative molecular mass is not given, you can calculate it. So let's calculate this of H2SO4. H2SO4, hydrogen is 1 times 2, plus sulfur is 32, plus oxygen is 16 times 4. That is 98 grams. Let's just call it gram. Alright? So we are in mass mole. So the mass is 98 grams of H2SO4 is equivalent to how many moles? 1 mole. Why? Because there's nothing in front. If it is 2 here, that's 2 moles. But there's nothing in front of H2SO4, so it's 1 mole. Take note. Now, how many grams will give us 0.05 mole? So if I have my X, I have 98 grams times 0.05 mole over 1 mole. The mole will cancel out. 98 times 0.05. 98 times 0.05. I have 4.9. This is equals to 4.90 grams. So that's that. Okay. 98 times 0.05. Am I right? Yeah. Okay. 98 times 0.05. 4.9. Okay, that's correct. Okay, let's move on to the next question. Calculate in grams the mass of this mole of gold. Aurum is gold. So let's clean the board. Question number 3 on mass mole relationship. Okay, you say calculate in grams the mass of 2 times 10 raised per minus 3 mole. 2 times 10 raised per minus 3 mole of AU gold. The relative molecular mass of AU is 197 grams. So let's start with that. We have our solution here. Gold, the mass of gold, the statutory symbol for the gold now is 197 grams, and that is equivalent to 1 mole. Okay, how many grams will give us this mole? 2 times 10 raised per minus 3 mole. So my X here is equals to 197 grams times 2 times 10 raised per minus 3 mole divided by 1 mole. Mole will cancel out. My answer now becomes this. (197) times 2 times 10 raised to the power minus 3 is equals to 0.394. 0.394 grams. So keep moving. Okay, which one do we just solve? Okay, calculate that of gold. Okay, we're done with that. Let's go to atoms mass relationship. Now, atoms mass relationship. Let's take our first question. Calculate the number of atoms. We're looking for atoms of element in 18.63 grams of lead. 18.63 grams of lead. The relative mass of lead is supposed to have been given is 207 grams. Solution. So we have lead, Tb. Now we say atoms mass relationship. So how many atoms of lead will give us how many grams of mass before we can establish? So now we know that 1 mole, this is 1 mole of lead. 1 mole of lead is equivalent to what? 6.02 times 10 raised to 23 atoms. So it can be used interchangeably. If I'm using 1 mole, or I'm using 6 point this, or I'm using 2.4 DMP, all of them are equivalent. So these atoms will give us what? Will give 207 grams. Now, how many atoms will give us 18.63 grams? My X becomes 6.02 times 10 raised to 23 atoms times 18.63 grams divided by 207 grams. This is equals to, cancel the grams. I have 6.02 times 10 raised to the power 23 times 18.63 divided by 207. 5.42 times 10 raised to the power 22. 22 atoms. So 5.42 times 10 raised to the power 22 atoms. We'll take another question. Let me claim this. We are still on atom mass relationship. Atom mass, okay, taking one. 2. Calculate the number of atoms of element in 0.2 grams of hydrogen molecule. What did I say, sorry? In 0.2 grams of hydrogen molecule. 0.2 grams of hydrogen molecule. Now they say we should calculate the number of atoms of elements in that. Solution. Hydrogen molecule. How many atoms would we have here? 6.02 times 10 raised to power 23 atoms. That's a constant. That is equivalent to the relative molecular mass of this is 2 grams. Now, how many atoms will give us 0.2 grams? Now, my x is equals to 6.02 times 10 raised to power 23 atoms times 0.2 grams over 2 grams. And this is equals to 6.02 times 10 raised to the power of 23 times 0.2 divided by 2. 6.02 times 10 raised to the power 22. 6.02 times 10 raised to the power 22 atoms. Okay, let's take another question. Calculate the number of atoms of element in 9.2 grams of sodium. 9.2 grams of sodium. So this is my sodium. Atoms, 6.02 times 10 raised to the power 23 atoms. It's equivalent to the grams is 23 grams. Now, how many atoms will give me 9.2 grams? So my x is 6.02 times 10 raised to the power 23 atoms times 9.2 grams all over 23 grams. This is equals to 6.02 times 10 raised to the power 23 times 9.2 divided by 23. 2.41. 2.41 times 10 raised to the power 23 atoms. .41 times 10 raised to the power 23. Okay, that's correct. Okay, let's take our, where are we? Atom mass. Okay, atom mass. Okay, let's go to mass-atom relationship. We'll try to hurry up so that I can finish them earlier, no? Let's go to mass-atom relationship. Now is mass-atom relationship. Calculate the masses in grams of 1 atom of sodium. 1 atom of sodium. We're in mass-atom relationship solution. So this is my sodium. Good. How many grams of sodium do we have? We have 23 grams of sodium. It's equivalent to 6.02 times 10 raised to 23 atoms. Now, how many grams of sodium will give me 1 atom of sodium? Now, my X is equivalent to 23 grams times 1 atom over 6.02 times 10 raised to 23 atoms. Atoms will go, and we're left with what? Let's see. 23 times 1 divided by 23 times 1 divided by 6.02, okay, plus 10 raised to the power of 23 is 3.82 times 10 raised to the minus 23. 3.82 times 10 raised to the minus 23 grams. Okay, let's take the second question. Question number 2. Calculate the masses in grams of 1.2 times 10 raised to 23 atoms. 1.2 times 10 raised to 23 atoms of aluminium. The question again, calculate the masses. So we are calculating the gram. Solution. Aluminium, the relative molecular mass of aluminium is 27 grams, and that is equivalent to 1 atom of aluminium, which is 6.02 times 10 raised to the power 23 atoms. Now, how many grams, we don't know, unknown, will give us 1.2 times 10 raised to the power 23 atoms? My X gives me 27 grams times 1.2 times 10 raised to the power 23 atoms divided by 6.02 times 10 raised to the power 23 atoms. Atoms will go, I'll be left with okay. I have 27 times 1.2 times 10 raised to the power of 23, okay, divided by 6.02 times 10 raised to the power of 23. I have 5.38. 5.38 grams. That's my answer. So you can call it 5.4 grams, however you want it. The third question on mass-atom relationship. The third question, we say calculate the masses in grams of 3 times 10 raised to the 24 atoms. 3 times 10 raised to the 24 atoms of what? Of helium. Atoms of helium, that's all. So solution, helium mass atom relationship. How many grams of this? We have 4 grams. The relative molecular mass of helium is 4. Will give us 6.02 times 10 raised to the power 23 atoms. Now, how many grams will give us 3 times 10 raised to the power 24 atoms? So my X is equivalent to 4 grams times 3 times 10 raised to the power 24 atoms divided by 6.02 times 10 raised to the power 23 atoms. Atoms will go, and this is equals to 4 times 3 times 10 raised to the power of 24 divided by 6.02 times 10 raised to the power of 23. 19.9 equivalently 20. So you see I call it 20.0 grams. So mass atom relationship. The fourth question there, let's take it as assignment. Calculate the masses in grams of 2.4 times 10 raised to the power 21 atoms of copper. So if you do that, then you take our next question to be, okay, let's take volume mass relationship. Volume mass relationship, and just solve some volume mass relationship or mass volume relationship, but let's take one. Let's take volume mass relationship. All gases, take note, occupy the volume of 22.4 dm³ at STP, standard temperature and pressure. So in volume mass relationship, let me change this. Volume mass relationship, let's see. Calculate the volume of 3.2 grams. 3.2 grams. Okay, of oxygen. Of oxygen. Now, they didn't tell us whether it is oxygen atom or it is oxygen molecule, but when we refer to oxygen, we always mean to be oxygen gas, and oxygen gas is always O2. So now, let's say we should calculate, what again? Calculate the volume of that solution. The volume of oxygen. So I have my oxygen here. Now, is volume mass relationship. How many volumes of this will be 22.4 dm³ of this will give me the grams of this, which is 16 times 2, 32 grams. Now, how many of you, the volume will give me 3.2 grams. Now my X is equals to 22.4 dm³ times 3 times 3.2 grams over 32 grams, and this is equal to this goes. Now let's see 22.4 times 3.2 divided by 32, 2.24 dm³. So it is 2.24 dm³ that will give us this. That's number one. Number two, Calculate the volume of 51 gram of hydrogen sulfide. 51 gram of hydrogen sulfide. We should calculate the volume. Solution. This is hydrogen sulfide. The volume of this is 22.4 dm cube. It's equivalent to sulfur is 32 plus 2, 34. So 34 grams. Volume mass. How many volumes will give me 51 grams? So I have my x. This is 22.4 dm cube times 51 gram divided by 34 gram. And this is equals to 22.4 times 51 divided by 34. 33.6. 33.6 dm cube. Let's take another question. Calculate the volume of 55 grams of carbon 4 oxide. 55 grams of carbon 4 oxide. Solution. Now, CO2 volume 22.4 dm cube will give us 16 times 2, 32, plus carbon is 12, 44. So this is 44 grams. The relative molecular mass. The volume is this and that. So how many volume of it will give us 55 grams? So my x is equivalent to 22.4 dm cube times 55 grams over 44 grams. And that is equals to, if I cancel my gram out, 22.4 times 55 divided by 44. 28 dm cube. 28.0 dm cube. Okay. In mass volume relationship, I'm going to solve one, probably one, and the rest will be assignment. So let's go back to mass volume relationship. Question number 1. Calculate the mass of 22.4 dm cube at STP of ammonia. 22.4 dm cube of ammonia, NH3. We should calculate what? Calculate the mass. Solution. NH3. So the mass, we have to know the relative molecular mass of this, which is nitrogen is 14, 15, 16, 17. So I have 17 grams, give me 22.4 dm cube, the same. So how many grams will give me 22.4? So it's 17. So we have x is equals to 17 grams times 22.4 dm cube all over 22.4 dm cube. So this will cancel this. I'm left with 17 grams. So they say we should still use the same value. Calculate, now this is your assignment, alright? Calculate the mass of 22.4 dm cubed at STP of chlorine molecule, that's 1. 2, nitrogen, dinitrogen oxide, which is N2O. So this is what it is. So when you calculate these two, you're done. That's assignment. So we're going to be stopping here. So with this, probably, we know that mole concept is the most important calculation in chemistry because it enables us to understand the preliminaries involved in resolving all calculations across board, volumetric analysis, Faraday's law of electrolysis, call them all the calculations you know. Without mole concept, we wouldn't have a full grasp of how these things go. So it is important we start with mole concept so that the other aspects are going to be easy for us, okay? So